So welcome everybody to this latest video on 162 Math, and in this video we'll be going over a quick topic test with a collection of exam style questions on inequalities. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now before we get started working through this test, it's worth noting that there is no indication about whether these questions are calculator or non-calculator, so we'll just assume that they are non-calculator. However, it's important to also note that inequalities can appear on both the non-calculator and the calculator paper. It's not exclusive to one paper. So let's get started on question 1. So question 1 refers to number lines, and it says here is an inequality where x is greater than 2. Circle the letter on the diagram which shows inequality on a number line. Now as there is no line underlining the inequality sign, that means we're looking for an empty circle, and the arrow is going to be pointing in the same direction as the inequality. So here the correct answer we should have is highlighting C. Then moving on to question 2, it says here is an inequality and we've got x is between -3 and 2 inclusive of 2. It says circle the set of integers that obey this inequality. Now just quickly going through how we do this. So if I write down all the numbers between -3 and 2, and if I look at the inequality next to each number, if it's got a line underneath it, I keep it, and if there is no line, I get rid of it. So here I get rid of the -3. So this is the set of integers that I'm looking for, and that is section B. Moving on to question 3, it says here is an inequality shown on a number line. Circle the algebraic inequality that defines the inequality shown in the number line. So here I'm looking for a inequality that hasn't been underlined, and here I am looking for where at the 4 it has been underlined, and the correct answer we should have is going to be our third option. Moving on to question 4. Now it's really important that you do read the questions carefully. Don't just simply look at a question without reading the text and understanding what the question is asking for. So here it says work out the smallest integer, so the smallest whole number that satisfies this equation. So here I've got 4x, and if I take the 3 over, I end up with 17. And so x is greater than 17 over 4. Now 17 over 4 as a decimal is 4.25. So the smallest integer that x can be, it's got to be bigger than 4.25, or the smallest integer therefore is going to be 5. Moving on to question 5, so we've got a double-sided equation. So here I've got a negative x, so I'm going to take that over to the side to make it positive. So I end up with 6x minus 6 is less than 3. Then I'm going to take this 6 over, so I end up with 6x is less than 9. And then divide by 6, so I end up with 9 over 6, which simplifies to give me x is less than 3 over 2. Moving on to question 6, and it's worth also noting, just double check the inequality sign in the question with the one you've written in your answer. Just make sure that you've not underlined it when you shouldn't have. So moving on to question 6, it says solve this inequality. So again, when we've got our algebraic expression in the middle, we want to try and get x by itself. So what do I have to get rid of first, the 3 or the -4? Well, it's going to be the -4, and I do that by adding 4. So then -7 plus 4 is -3. And then I'm left with 3x in the middle, and 9 plus 4 is 13. Then dividing both sides by 3, or all sides by 3 even, we end up with -1. We end up with x in the middle, and 13 over 3, which can be written as 4 1/3. And you can either write your answer using fractions, or you could write it as a decimal or as a mixed number. It's entirely up to you, but as long as it's 13 over 3, then that would be absolutely fine. Moving on to 6b, again we've got another number line. It says here is an inequality drawn on a number line. Write down all the integers that obey this inequality and the answer in part A. So looking at the answer in part A, we want values that are between -1 and 4.3 recurring. So let's just write that down. So -1, x, and 4.333 recurring. Let me just double check to make sure that there's no underlining. Oh, there is one at -1. Now the integers that satisfy this one are -1, 0, 1, 2, and 3. So for this, I need to make sure that it's within the range of A and it's within these numbers. So I'm looking for which numbers satisfy both. So it's going to be -1, 0, 1, 2, and 3. Now, coincidentally, that is just the integers that satisfy the number line, but it's obviously worth just double checking to make sure that you've looked at the range of values in 6a. Now, for question 7, it says all measurements are in centimeters. This rectangle has sides of 3x plus 4 and 2x minus 3. You're given that the perimeter is less or equal to 55 centimeters squared. Find the maximum area of the rectangle. Now for this, what we need to do first is find out what the maximum x value is going to be. So what I need to do is first of all work out algebraically an expression or equation that represents the perimeter. So the perimeter is where I add up all of the sides together. So I've got two lots of 3x plus 4 plus two lots of 2x minus 3. And I know, and I'm just going to get rid of that p equals. We're looking at the perimeter. That based on this information is less or equal to 55. So from this, if I expand the brackets, I'll get 6x plus 8 plus 4x minus 6 is less or equal to 55. So I end up with 10x plus 2 less equal to 55. So 10x is less or equal to 53. So x is less or equal to 5.3. So the biggest value x can be is going to be 5.3. So let me just write that down. So the biggest value of x equals 5.3. Now, if the greatest value of x is going to be 5.3, so that means then one side, so 3x plus 4 is going to be 3 lots of 5.3 plus 4, which gives me an answer of 19.9. And if I substitute 5.3 into 2x minus 3, I get a value of 7.6. Now, if I multiply those two measurements together, I get a maximum area of 151.24. Now, moving on to question 8. Now, question 8, at face value, might seem absolute bamboozling. I'll be honest, the first time I saw this, I was like, what on earth? Because it doesn't make any sense. So it says all measurements are in centimeters. Here is a triangle. Work out the values of A and B such that X is between these two numbers. Now, you might think to yourself, well, hang on a second. How does this even work? Where is A and B actually come from? Now, basically what this question is looking like kind of combines you constructing triangles. Now, when you're constructing triangles, one of the key principles of a triangle is that the sum of any two sides must be greater than the remaining third side. So let's have a look at doing that. So if I take any two sides, so let's just say these two sides here, then what that means is that x plus 3 plus 2x plus 4 must be greater than 10. Now, if I pick another two sides, let's go for these two sides here, so that x plus 3 plus 10 must be greater than 2x plus 4. And if I pick the other remaining two sides, let's go for this one and this one, that 2x plus 4 plus 10 must be greater than x plus 3. Now what I'm going to do is I'm just going to put a little asterisk next to each one. So looking at equation 1 first, but what we're going to do is we're going to find the value of x. So here I'm going to end up with 3x plus 7 is greater than 10. That then leads on to 3x is greater than 3. So x has got to be greater than 1. Then looking at equation 2, we end up with x plus 13 is greater than 2x plus 4. And if I just do a little bit of rejigging, I get 9 is greater than x. So that's another equation. And then with 3, I get 2x plus 14 is greater than x plus 3. And simplifying that, I get x is greater than minus 9. So looking at each of these criteria, what I'm trying to do is find a possible range of values of x. So x has got to be greater than 1. it's got to be less than 9. And so let me just rejig this one here. Now, if I flip the order in which the number and the letter are written, I need to flip the inequality. So x has got to be greater than 1. It's got to be less than 9. And has also got to be greater than -9. So what possible values of x could x be for it to satisfy each of those particular criterias? Well, the ones that it's got to be is this one here and this one here, because obviously any number for the bottom one, x has got to be greater than -9, but if it's -8, it'll be outside that top hashtag 1. So the range of values of x are going to be 1. I don't know why I'm writing in a highlighter there. So then the answer for this particular question is going to be 1, x, and 9. I don't know why I've underlined that, so let me just get rid of that. And there is my final answer for this particular question.